everyone, Jeremy Blum here with Arduino tutorial number 7, sponsored by Element 14. This week I'm going to be talking about the I2C bus, also known as the I2C bus or the Inter-Integrated Circuit bus. In addition to that, we're also going to play around with processing a little bit more, which we started using last week. And at the end of this episode, we'll make an I2C temperature sensor powered thermometer that displays the temperature in your room in Celsius and in Fahrenheit on your computer screen in a nice little readout. And it should be really cool. So let's get started and learn a little bit about I2C. Here's a rundown of how we're going to set up I2C in our circuit. The Arduino will be configured as our I2C master, and the temperature sensor will be configured as our I2C slave. You can have several slaves on the same line on an I2C circuit, as long as they each have different IDs. The ID comes pre-configured on the integrated circuit at the time of purchase. You can sometimes request to have a special ID preset, or you can buy them with IDs already set into them. In this case, we're using one with an ID of 72. There's a shared data and clock line between all devices on the bus. So what that means is that you can communicate with several devices, but only be using two wires to do so. Communication happens in both directions on the SDA line. On the Arduino, the SDA line is connected to analog input 4, and the SCL line is connected to analog input 5. Basically, when you initialize the I2C interface on the Arduino, it takes over those inputs. They can be used for more than just analog input. The other important thing to remember with I2C is that you need pull-up resistors. I2C is active low, which means the values need to be pulled low to be considered a logic 1. So we use a 10K resistor to pull both lines up to 5 volts so that they default to a 5 volt signal when not being pulled down by the master or slave. In order to get our Arduino communicating with temperature sensor, the first thing we'll have to do is have it specifically asked to talk to ID number 72. This is so that we don't get interference from anything else that we have on the bus. Although in this case we'll only have the temperature sensor connected. This particular temperature sensor is configured to store the temperature in the room in degrees Celsius in register 0. So the next thing we'll do is ask for the data in register 0. Next, we'll stop talking and then wait for 1 byte response to come from the slave or ID 72. That 1 byte response will contain the temperature in the room in degrees Celsius. Once we've received that response, we'll be able to do whatever we want with it and send it to the computer to do all kinds of cool stuff with. Before we can get our I2C temperature sensor hooked up, we'll have to see what the pinout is on it so that we can connect it to our microcontroller. To do this, just search the part number that you find on the component. On the component it says TC74A0. So you just type that into Google and we can see that the first thing that comes up is a PDF with the datasheet of the device. Excellent. Alright, we want to look for the pinout. Here it is. This is a 5-pin device, and we're using the DIP version, not the surface mount version here. So we can see at the first pin there is NC or no connection, then the data line, the ground line, the clock line, and the voltage line. So let's get that hooked up. Here I have the I2C temperature sensor all wired up to the Arduino. Note that I have the power and ground rails heading over to the power and ground rails on the breadboard, and I have the appropriate pins on the I2C hooked up to power and ground. Also note that the clock line from the I2C temperature sensor is connected to analog input 5, and the data line is connected to analog input 4, as is specified on the Arduino website if you look up the I2C interface. Also note that I have the 10K resistors connecting between the data and clock lines to the 5 volt rail as pull-up resistors. Now let's get this programmed. Now it's time to write a simple program that will grab our Celsius data from the I2C temperature sensor and send it to the computer. So the first thing we'll do is import our I2C library, which in Arduino is called the wire library. So we'll import wire.h, and remember there's never any semicolons after an include, unlike everything else. And let's set our temperature address, which remember was 72 for our sensor. Temp address equals 72. Okay. In our setup, we're going to need to make sure that we start our serial connection because we'll be talking back to the computer. Same as always. And we'll also have to do wire.begin, which will initialize the listening on the I2C communication bus. Okay, I've already outlined everything that we need to do in the loop, so let's just fill it in. The first thing we're going to do is start talking to the I2C temperature sensor. The command to do that is called begin transmission. Begin transmission. And we have to input the address that we'll be talking to, which we stored up above. So that'll start talking to it. That'll let it know that that's the ID we want to talk to. The next thing it's going to do is it's going to send a 0 to it to ask it for the information in register number 0. So we'll do wire.send, and we're going to send it a 0. Okay, we're now done transmitting to it, and all we're going to do now is wait to get information back. So let's end the transmission. So we started the transmission 2 lines earlier, and now we're going to end it using a similar command. Although you don't need to specify the ID this time because it's already connected to an ID. Okay, now we're going to be waiting to get 1 byte back. So we'll do wire.request from and the temperature address and the amount that we want to get back, which is 1 byte. Okay, now we just wait. So we wait for a response here. And this is just like we did last time. We're going to put it in an infinite while loop that will keep repeating until we get the information that we want. So we're going to do wire.available. This is just the same as with serial. Equals 0. And wait for our answer. And when we do get the answer, that will be our temperature. And I'll set that to the variable C for Celsius. So we'll do wire.receive. And we'll get the temperature. Okay, now let's keep going here. We also want to get temperature in Fahrenheit, which we can do with a simple mathematical equation. If you don't know the conversion from Celsius to Fahrenheit, just Google it. It's very simple. And we'll set that equal to F for Fahrenheit. So the equation for Fahrenheit, first off, we're going to round it so that we get an integer. Because in general, you're probably not going to get an integer when you convert from Celsius to Fahrenheit. So to do that, you multiply C by 9.0 divided by 5.0 plus 32.0. And the reason I'm doing 9.0, 5.0, and 32.0 instead of not having the decimal places there is because we know that we're probably going to get a number that's not an integer when we do this, and we want to make sure we're multiplying it by other numbers that are also floats so that we don't lose any data. And that's what adding the point to it, the 0 accomplishes. Now, let's just print the results to the screen. Serial.print. First we'll print the Celsius address. Then we will print the C to indicate that it's in Celsius. And we'll put a comma after it so that we can print Fahrenheit. So note that I'm not doing print ln, I'm just doing print. This ensures that we don't have a character return after it. So it'll print out the number and then the letter C followed by a comma right after it. And then after that we'll do serial.print. And we'll print the temperature in Fahrenheit. And then we'll print in capital F to indicate our unit of measurement. And now, so it's easier to read, we can make this last one print line so that it goes to the next line afterwards. Okay, and then just let's do a delay so we can actually read what's coming up on the screen in a reasonable amount of time. Do delay 500. Okay, let's see how this works. So now we have the program uploaded to the Arduino. Let's see what happens when I squeeze the temperature sensor and heat it up. Alright, perfect. The temperature goes up from 25C to 26C, or 77 to 79 Fahrenheit. I guess it's pretty hot in my room. It must be all the computer equipment that's running right now. Okay, great. Now let's make this display something really awesome on the computer instead of just in the terminal window. The first thing we'll do to accomplish that is we're going to get rid of the line break here. And we're going to replace it with a period. And this will just make it a little bit easier to delineate between the information when we bring it into processing. So let's get that onto the Arduino, and then we'll go into processing and do some awesome stuff to make it look pretty. Now we're going to create a processing program that can grab the data over serial, break it apart into the important parts, and then display those parts on the screen in pretty looking text. The first thing you want to do is create a font that processing can use to display the text on the screen. Go to Tools and hit Create Font in the processing control window. Choose any font you want. I'm going to choose Agency FB Bold because I think it looks good. And I'm going to make it big, size 200 font. This will automatically make the font you need. You might want to copy this font name because we're going to need it in a second. And then hit OK. Okay, we've created a font. Now let's get this program set up. I've already written some of it for us. The first thing is you're going to import the serial controller just like we did last time. And you're going to create a new serial object with name port. These are the variables that we're going to use. Temperature C will hold the temperature in degrees Celsius. Temperature F will hold the temperature in degrees Fahrenheit. Data will hold the entire string that comes in over serial so that we can break it apart into the pieces we want. Index will represent the location in the string where the comma is. The comma will represent the difference between Celsius and Fahrenheit so that we can find that. And then we're going to make a new font called font of type pfont, or processing font. And that's what we'll need to write the text on the screen. Okay, so I'm going to make a new canvas of size 400 by 400. This is similar to last time, and set up our port 9600 baud on COM3. Okay, the first thing we're going to do here is tell the port to keep looking until it gets to the end, which remember we denoted with a period. So we'll do buffer until, and then we'll look for that period. That's how it'll know it's time to move on to the next one. Okay, now we're going to set up that font that we just created. So we'll do font equals load font. And remember, you can find all this information on the processing website. This is how I figured out how to use all the font commands. I just went to their website. And now I'm going to paste in that thing I just copied. And make sure you put .vlw at the end of it, because that's the file type. Put it in double quotes. So what that's doing is that's setting our font that we set up here to have this font. So we have that set up, and now we're going to call text font on that. Choose the font that we just set up and the size. This is actually optional because I already set it 200, but I'm just going to do it anyway just for fun. Okay. In the draw, remember, draw keeps getting refreshed repeatedly to draw an image on the screen. We're going to start off with a background of 000, which is just black. We'll keep the background black. The fill command will change the color of the next object that we make. You can figure out how you want to choose these RGB color values by just going online and looking for an RGB color selector. That'll let you pick out a color, and it'll basically return these three values. This is the amount of red, the amount of green, and the amount of blue. So that's the color I've chosen for the first one. You'll be surprised and see what it looks like. And to make that first one, now that we've chosen for the color for it, we're going to run text. We're going to print out temp-c, which we're going to grab later, but it starts off as an empty string. Remember, you have to initialize it to an empty string so that this doesn't throw an error the first time it runs. And then the next two parameters are just the coordinates on the screen. I just kind of guess and checked until I found that these parameters worked and put it more or less in the center. But you can adjust those to however you want. This is the x coordinate and this is the y coordinate. Next, we're going to set up our fill for the Fahrenheit temperature, which will go right below the Celsius temperature. So for that, I chose 0, 102, 153, which is a different color than above, of course. And then we'll generate that text based on the content of our temperature Fahrenheit that we're going to figure out how to grab in just a second. So that'll be temp underscore F 70, 370 are the coordinates that I found worked. Okay. And note how the x coordinates are the same for both. We want them to be left justified. Alright, great. Now all we have to do is write our serial port event, which is going to do something whenever we basically get that buffer. It's going to do whatever comes before that buffer. Okay. So the first thing we'll do is we'll use that data variable that we set up earlier to grab the entire stream that comes in. So we'll set data equal to port.readString until, and just like before, make sure you have the same value here as you do up here. We're going to read the string until we get up to that dot. Next up, when you do read string until, it actually includes the dot, but we don't actually want to show the dot in our text. So we're going to do something called a substring. And what that's going to do is we're just going to reset data to be the same thing without the dot on the end. So you can run data.substring. 0 to data.length -1. And all this command does is it basically removes the period from the end of the data string. And we know that there's always going to be a period there, of course. This just says start at the first character and go to the last character -1. And that's what creates the new data string. Okay, so now we're gone with our period, which is what we want. Now we want to look for our comma. So remember, always comment your code. And we'll do index. Remember, we set index up here. Index is going to be the location in the string of our comma. You can think of a string as a list of individual characters. Each character has a location in the string that's called its index. Index will be data dot index of, which is a function that finds the comma in our string. So that's going to find the comma and tell us at what point in the string the comma is located. That way we can grab the stuff before and after it. Okay, now we're going to fetch the Celsius temperature first off and store that in temp C, because remember temp C is what gets drawn on the screen. And we'll do temp C equals data. We're going to use substring again so that we don't get that comma and so that we get the part of it we want. We're going to go from 0 to index, and index is not inclusive, so if the comma is at 5, and this is basically saying go 0 to 5, it's not going to include the comma. So we don't have to worry about doing -1 or anything like that. And then we're going to fetch Fahrenheit. Comment it. Temp F is going to equal data dot substring. This one is going to go from index +1, right? Because we wanted to get the first letter after the first number or letter after the comma. Index +1. Data dot length, and data dot length just returns the last index. Okay, and that should do it. Let's see if this makes a very pretty temperature display. Alright, look at that, very cool, huh? And I'll squeeze the thing here and we should see the temperature change. Yep, looks good. And remember, you can change those colors by changing those RGB values that I showed you earlier. And it'll update on the screen. And now you can use your Arduino as a thermometer for your room, if for whatever reason you want to do that. And you can do all kinds of other great stuff like this. You could have it turn on an alarm on your computer when it gets up to a certain temperature. You could do all kinds of stuff. In fact, I look forward to seeing what kind of stuff you guys do with processing in the Arduino. Thanks for watching this episode of my Arduino tutorial series. As always, if you have any questions, please feel free to ask me on YouTube, on my blog, johnweeblum.com, or on Element 14. And if you want access to the source code or schematics for this episode, I always make them available for download on my blog. There's links in the video description below. If you have any questions about how to use processing, you should definitely head over to the website. They have a ton of examples that you can use to work through how the processing environment works if you're just getting used to it. In fact, I myself am no expert at processing, and I checked out their website quite a bit to put together this tutorial today. So if you have any questions, stop by there or ask me and I can try to help you out too. I hope you guys enjoyed this episode, and I'll see you guys next week. Thanks to Element 14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.